in this lesson we're going to be working more with reference angles. So we're going to first of all sketch angle theta, find its reference angle, theta prime. However, in order to do that, we have to be sure that we're working with a theta that is between 0 and 2 pi. So we may have to do some conversions to start. So when you look at the first one, it's theta equals 7 pi over 3. Well, 6 pi over 3 equals 2 pi. So this angle is larger than 2 pi, so we need to do the conversion. So what we're going to do is subtract 2 pi from it, and that gives us pi over 3. So pi over 3 falls about right here. So this is in quadrant 1, and if we have if our angle falls in quadrant 1, then the reference angle is the same as the original theta. So in this case, theta equals theta prime. So it's pi over 3. So the next one, our denominator is 6. Well, if our denominator is 6, then 12 pi over 6 is 2 pi. So you can see that this one is larger, so we need to make that adjustment. So I'm going to subtract my 12 pi over 6, and I get 5 pi over 6. So this is 3 pi over 6 because it's half pi, and here is 5 pi over 5. Over 6, excuse me. So our 5 pi over 6 is going to fall about here. So this is quadrant 2. So if our angle theta falls in quadrant 2, what we have to do is to take our pi, which in this case is 6 pi over 6, and subtract our theta, 5 pi over 6, and we get pi over 6 for our theta prime. Okay, for number 3, we have 6 pi over 5. So 6 pi over 5, here is 5 pi over 5. So 5 over 5, or 6/5 pi, is going to be a little bit more than that, so it's going to fall in quadrant 3. So if we have angle in quadrant 3, we take our original angle theta and subtract 180, or in this case we're working with radians, so let's subtract pi. So we have theta, which is 6 pi over 5, minus pi, 5 pi over 5, and I get pi over 5 for my theta prime. Okay, so number 4 looks a little different because we have the decimal with the pi. And so just think about that as this is 1 3/4, or looks kind of strange like that. So let's write it in a more familiar way of 7 pi over 4. And I got that just by doing the mixed number conversion. So in this case, 7 pi over 4 is 1, 2, 3, 4, 5, 6, 7. So this would be my 7/4 all the way around here. So this one falls in quadrant 4. So when it's in quadrant 4, I take 2 pi, which in this case I'm going to use the substitution 8 pi over 4, minus my theta, 7 pi over 4, to get pi over 4, which would be my reference angle right here, theta prime. Okay, so the last two are different because they're both negative. So remember that one of the stipulations is that we want it to fall between 0 and 2 pi. So once again, we're going to have to do the conversion. So let's first of all find the coterminal angle for negative 3 pi over 4. So to do that, I'm going to add 2 pi. And that gives me 5 pi over 4. So 5 pi over 4 falls about here, which is in the 3rd quadrant. So what I'm going to do is take my theta, subtract pi. I'm using 4 pi over 4 because that's the equivalent of pi, and then I get pi over 4 for my reference angle. So my reference angle is right here. Okay, and this one is negative pi over 7. So again, we have to do the conversion because of that negative. I'm using 14 pi over 7 as my substitution for 2 pi. Okay, so when I think about 13 pi over 7, that's almost all the way around here. Okay, so this is in quadrant 4. So I take my 2 pi and subtract my 13 pi and get pi over 7 for theta prime.